is going off again.
Now, what we're going to do before we start new material is go through the exam you did. So let's have a look at the questions. Right. Question the first. Right, so a boat sails 7 to the east and 9 to the north. What is the magnitude and direction of the boat's velocity vector? 7 east and 9 north. I was expecting everybody to get this right, but I was disappointed. 7 to the east and 9 to the north, so that would look like... Fahad, if you have a question, please don't interrupt me in the middle of speaking. I don't know why you do this all the time. You know how much it annoys me and how rude it is. Now, just for that, I'm not showing you the papers today. You're going to have to wait later in the week. No. You're going to have to wait now until Friday, just for that. Maybe this will help you develop some manners, okay? Right, 7 to the east and 9 to the north. So 7 meters per second to the east, 9 meters per second to the north. So the vector is like this. So the magnitude, if I call this vector here x, the magnitude of x will equal square root, yes? Question?
How are you calling this?
Yes. Square root 49 plus 81. Square root 49 plus 81, which is 11.4 meters per second. And so many people forgot the theta. It was crazy. Tan inverse 9 over 7. So that will be 52. Yes. Hey, you're late. How come? Oh, come on. Sit down the back. 52.13 degrees. So the answer is 11.4 meters per second east, 52.13 degrees north. So like I said, I expected everybody to get that right, but I'd say the success rate here was maybe 60% or so. It is. For some odd reason, I don't know why, but for some odd reason, the people, like everybody got this part, but a few people forgot about this part. I don't understand it. Anyways, that's life. Can we go to the next one? Yeah, you're writing this down, Takin? Yeah? You got it? Yeah. Right, so this one here, a girl throws a ball up in the air 1 meter from a height of 1 meter with a speed of 29. How long until the ball hits the ground? Okie doke. So here she is. And this height here is 1 meter. And we'll take this here as ground level. So what's going to happen is the ball is going to go up and down and hit the ground here. And the speed at the beginning is 29 meters per second. How long until it hits the ground? So this is just your regular U, V, A, T, and S. 29, don't know, minus 9.81, don't know, and what about the S?
1 meter plus something.
That's a zero.
You are failed. Huh?
Zero.
1 meter.
Try it again.
29 meter.
Wow, getting desperate now. Getting really, really desperate. No, nobody. Nobody. Go on.
-1.
Finally. -1. Forgot this. KJ.
In the exam, I think I just did 9.21.
You put in +1. So you would have found the time, it would have been 1 meter above the starting point, basically. Sorry, is that what I want? Is it the time I was looking for? Yeah. Is that okay? Yeah.
You can do this in 2 parts too.
Time to max height?
You find just the pole and then
Say that again?
just find from ball to the zero, VBC 0 at the top.
This time?
Yeah.
Yep.
And then find the from here to the bottom.
Yes, this is fine. It's longer. It'll get the same answer. And that is absolutely fine. This is the quickest way. I will use the formula S equals, I think. S equals UT plus a half AT squared. So -1 equals 29T minus 9.81 over 2T squared. So I have 4.905 T squared minus 29T minus 1 equals 0. -1, my friend. -1. I took everything to the left. So 4.905 minus 29 minus 1. I get 2 answers by using the quadratic formula. Second answer is negative, so we won't even talk about it. So therefore T equals 5.95 seconds. It all looks so easy now, doesn't it? So easy. What was the problem? Why was I so confused in the exam? Why did it seem so difficult? No, everybody I'm talking about. Alright, did you write this down? Did you write this down? Yes? You wrote this down? Are you writing anything down?
No, because I know my answer is this.
Write it down. I don't care. I'm not doing this for fun. Even though it looks like I'm having a great time. I'm not. This isn't a movie. Don't just sit back and relax. Did you get the first one right? A1.
I think so.
You think so?
Because I remember half of it.
Yeah, well maybe the other half is wrong. Maybe you're one of those people that didn't give me the angle.
No, because I remember that angle. Because I was confused to how to put E between like this. Because I remember that.
Okay.
Maybe my angle could be wrong.
So maybe it's a good idea to write everything down in case you remember something incorrectly. Maybe another question has an answer of 5.95.
No, because I did this.
Maybe.
in 2
It's
parts.
possible that you're wrong. I know it's difficult to believe this, but you must accept this as a possibility.
No, I'm just saying. Because I remember this. I did this in 2 parts.
But maybe your answer wasn't 5.95. Maybe that was to another question.
Maybe.
Possible? It's possible.
Yeah, maybe.
I mean, it was like a month ago. Alright. The A3 is one which was very badly answered. Or maybe I should say not badly answered, but a very common mistake here. So what you had is, this car moves with this speed, and this car moves with this speed, and they collide. But so many people, in fact, possibly everybody, overlooked this part of the sentence, opposite direction. Meaning that this speed was 18 and its velocity was 18, but this one had a velocity of minus 14 because it's going in the opposite direction. Yes? What's wrong, Catherine? Everybody did this wrong, I think. Are you sure? I'm pretty sure that everybody did this wrong. Everybody, I think, went plus and plus. You think you did a minus in it? Don't know about that now, KJ. Anyways, the first one, 1768 and 18. (1768) kilograms and 18 meters per second. And then the other one is 1877. And what did I say? 14 meters per second?
Yeah.
So they collide. Find the speed of the wreckage afterwards. After the collision, do you think the wreckage will be heading to the left or to the right?
Right.
You are correct. Because the car on the although the cars are equal, the cars are roughly the same mass. The one on the left is going faster, so this would mean the momentum of the wreckage would continue to the right mostly. Okay, so the mistake everybody made, except for maybe one person, possibly, I doubt it though, was that everybody forgot to put the minus on the 14. So when people did this question in the exam, they were basically doing it this way. Problem. Okay. So anyways, U1 is 18. M1 is 1768. U2 is 14. M2 equals 1877. And you have the formula M1U1 plus M2U2 equals, and then the wreckage's mass will be M1 plus M2 times V. Whatever this, the mass is added together, which would be 1768 plus 1877, 3645 kilograms. Movement to the right with V. Okay, so you have 18, 1768 plus 1877 times minus 14 equals 3645 V. So V equals. And the answer is 1.52 meters per second. Yeah?
That was too cliche.
that it's very wrong? Your water is red?
Like a blood.
Wow.
So very disgusting.
Have you considered calling a priest? No, okay. I don't know, Tecking. You'll have to talk to your landlord as soon as possible. Red.
Yeah.
Very red.
Everywhere, sink and toilet and
Wow. When did this start?
Saturday.
Right. Did you call your landlord?
They are holiday.
Oh,
When I take a shower, I was fine.
yes, I would be too. We would be too. When are they back from the holidays?
I don't know.
Call Irish Water, actually. Irish Water is the water company that provides the water. Tell them the problem. And also ask your neighbour if they're having the same problem. If your neighbour's having the same problem, call Irish Water. It means it's a problem with the area. If your neighbour is not having the same problem, there's something wrong somewhere in the house. Your landlord needs to fix it. Also, talk to Alison. You know Alison? Talk to Alison. Yeah. Alright, next one. Did you write this down? Yeah. Right. So a moon orbits a planet, and it's 28 days to orbit, and the moon is 342,000 kilometers away. Right. So we have some kind of planet. Let's make it Earth. And then we got our moon going around. KJ, I choose you. Right. So this distance here is or, and or equals 342,000 kilometers. So that is 342,000 meters. Which is, what's that now? Let me have a look. 1, 2, 3, 4, 5, 6, 7, 8, is it? 3.42 times 10 to the 8 meters. The time is 28 days, which equals 28 days times 24 hours a day times 3,600 seconds in an hour, which is 2419200 seconds. Or if you want, (2.42 times 10 to the 6 seconds). Okay, and what was my question? The acceleration, yep?
If it's rounding up, it won't change the answer.
Oh well, but that's okay. I don't mind. I don't think these are too many numbers to type in, so you could probably leave them like this. Okay, so we want the acceleration. So we have two formulas we can use. We have F equals ma, and we also have F. Well, actually, no, we can just directly use the formula for circular motion. A equals, what is it, omega squared or. But remember that T equals 2 pi over omega, so omega is 2 pi over T. So this equals 2 pi over T squared or, which would equal 2 pi over 2419200 squared times 342,000,000 So therefore you get A equals, if we just hit that in, it should be quite a small number, which it is 2.31 times 10 to the minus 3 meters per second squared. So, not so difficult, huh? Okay. Next. Yes? Right, so now on to electricity. So two resistors in parallel, 3, 9 and a 4 volt battery. What's the current? Three ohms, 9 ohms, and a 4 volt battery. Oh, sorry, I said cell, so I'll just draw one image. No, sorry, did I say battery here? Battery, yeah. 3, 9, and 4 volts. 3, 9, and 4 volts. Alright. Let me clean that up a little bit. Okay. Alright, so there are two resistors. So first piece of business is get the total resistance. 1 over R equals 1 over 3 plus 1 over 9. So 1 over R equals 4 over 9. So R equals 9 over 4 ohms. Then we can use good old V equals IR. So then I equals V over R, which equals 4 over 9 over 4. So I equals 16 over 9. So that's 1.78, not ohms, what am I talking about? Current, amps. Checking something, KJ? No, why are you checking? What do you think's wrong? Let me know. Not too difficult again. See, I thought my test was too easy. But the lack of A stars meant, no, it wasn't too easy. Or my students weren't too good. What do you think? I don't think it was too difficult. I don't think there's been a difficult question yet. Really difficult.
We're still in the B section.
Oh, I know. Wait till you get to the B section. Paradise of easy questions. Right, 6, what have we got now? 2 capacitors, a 5 and a 9 in parallel with a 5 volt cell. So capacitor, a cell, 5 volts, and it's a 5 farad and a 9. And my question is, how much energy is stored in the combined capacitors? So the total capacitance, when they're in parallel, will be 5 plus 9. So that's 14 farads. And the energy stored, or the work, I'll just write energy. the energy stored, the formula is a half CV squared, so that would be 7 times 25, which is 175 joules. These questions are supposed to take 5 minutes to do. I don't even think it's 5 minutes. Okay. Continue. Number 7 was badly answered. 6.13 millifarad is first charged through a potential difference of 4 and then allowed to discharge through a capacitor of 8.75 kilo ohms. Okay. So what you have here is your capacitor, and then it's allowed to charge up. So while it's charging, it's being charged with a 4-volt cell, and then the capacitance here is 6.13 milli, and then the resistance here is 8.75 kilo ohms. So in red we charge it up and then we disconnect, and then the capacitor is allowed to discharge through the resistor. So whatever the resistor does, maybe it lights or heats, gives off heat or light. So anyways, that's what you're looking at here. How long for the capacitor to discharge? So anyone remember the formula for the time to discharge? No, what? Say what?
5 time constant.
Is what?
Time for it to discharge.
Yeah. So you're looking at the time to discharge is 5 time constants. And do you remember what a time constant is?
Minus 1 hour.
I don't think you need the minus. Time constant is RC, isn't it?
Yes.
The time constant is equal to R multiply C. So this would be 5 RC, which would be 5 times 8.75 kilo times 6.13 milli. Now, what else did I ask? How long in minutes? So this will equal 268.1875 seconds, which is 4 minutes and 28 seconds. Yeah. Did you? Because again, like with the momentum question, I think most people got this one wrong. Yeah. Maybe one person. A star. Maybe. Huh? A's?
What was the common result?
Don't know. I just know I was disappointed. Put down, please. Are you cold?
Yeah.
Really? You're always asking to open the window.
Because I closed the curtains also.
You're sick?
No.
I'll take the hood down. Are you sick? No?
No.
cold. Really? What happened to you? Before Christmas you were all, oh, open the window and hot, it's
It
hot
just
in here.
came from the heater on the bed.
Ah, no, this is better for you, it'll wake you up. Alright. We got 6 written down? Yes? Yes? Okay. 7.
8:50 when I was in
No, that wasn't 6. That was 7. Alright, 8 now. A crane. Oh yeah, no, this one was terribly answered. Terribly answered. A crane lifts a mass of 1490. Right. So what you have here, you have a mass of 1490 kilograms, and a machine, whatever, lifts it up a distance of. So here's my machine here. Look, I'll even draw a little man here operating the machine. Right, 9.62 meters in a time of 17.6 seconds. What is the power of the crane? Now, maybe I'm being a bit harsh. It was badly answered insofar as nobody got the right answer. I don't think anybody got the right answer here. But a lot of people had a good try at it, but nobody quite did it the right way. What you're supposed to do here, I mean, a lot of people worked out the velocity of the mass, but as if the mass just fell from Earth, you know. Didn't quite work out. So power is equal to work over time. Now we know the time. That's no problem. The big problem is, what's the work? Well, when the mass is on the ground, what energy does it have? So here's the ground. Here's the grass here. Little flower. Right, there's the grass there. How much energy does this have when it's on the grass? Has 0 joules. When it's up in the air, when it's reached the top here to be with the man, what type of energy does it have? Potential energy. Just potential. It's not moving. So it's potential energy equal to mgh. Previously, it had no energy, and then at the end, it had energy. This energy must have came from the machine. The machine provided the energy. Therefore, the machine did this much work. So in fact, the formula is just mgh over t, which is 1490 times 9.81 times 9.62 all over 17.6. If you round it off, I mean, it's 7989 watts. It's nearly 8 kilowatts. You could say that's 7990 watts, or if you want, you could give the answer 7.99 kilowatts. What do you think? So I don't think anybody did it this way. I
remember this formula.
Which one?
Work over time, but I don't remember any change.
Yeah. answered. Well, not badly answered. I mean, the way people were doing it, they were making it much, much more difficult. And now that you see it, you can see it's actually quite easy, right? KJ? What's wrong with you? Sorry, what else is wrong with you? It's okay? Yeah? Alright, let's have a look at 9 now. Oh yeah, I think this is badly answered as well, because I think people mixed up water and air or something stupid like this in the formula. I don't remember. Anyways, light travels from air to glass, and the glass is 1.45 and it's 41 degrees. So what you have here, I'll draw that here. Here's the glass. Then here's the air. And here the n is 1. And here the n is 1.45. And then this line perpendicular here, this is the normal. So what happened was the air, it comes in at, 41. So the light comes in here, an angle of 41 degrees. And then the, sorry, that's quite, then we'll call this angle here or. The angle of refraction, the angle it leaves out. So the formula is sine I over sine or equals 1.45 over 1. I don't know what happened. People had this upside down, or I don't know. It was a disaster. Okay. So after rearranging this, you get sine or equals 0.4525. So then that means or equals sine inverse 26.9 degrees. That's that.
According to you, the question has been answered badly.
No. The questions that have been answered particularly badly. 1, I was surprised that so many people only gave me half an answer. 2 was not answered so well. A lot of people forgot about the -1 business. 3, a lot of people missed, in fact nearly everybody I think, missed opposite direction. 4 was mixed. I think 5 and 6 was answered well. 7, a lot of people forgot the 5 in the time constant, 5 time constants. 8, people made more difficult. 9, people mixed up the N1 and the N2, I believe. Now on to 10.
What's our result then?
Huh? What's that?
So what's our result could be?
I'll put it on the notice board. I mean, I can...
You didn't?
No, I said I will put it on the notice board. But I mean, yeah, you might not want to be rushing to have a look at it.
It's not that bad.
It's not that great either.
No, it's like good.
Yeah, I'll put it on the notice board, but like I said, don't run to the notice board. You might be disappointed.
No, you just give us the end of the class, that's fine.
If you like. Alright, can I go to the next one? A10? Okay, stationary sound wave. Closed at one end pipe. The frequency of the tuning fork used to produce the stationary note wave is 1100 Hertz and the pipe is 0.76 meters long. Use this information to estimate the speed of sound. Right, so you got your pipe It's 0.76 meters long, and it's closed at one end, and your tuning fork is here that makes the sound, and this frequency is 111 hertz. So we want to draw it in carefully. So this end here will be a node, and this end will have an antinode. So it'll look like this as this moves up and down. Okay, so you can see that the wavelength will be 4 of these. And then you have your formula V equals lambda F, isn't it? Which will equal 3.04 times 111. And we're finished. 337 meters per second. I don't remember how well this question was answered. I think it was answered okay. I think.
I'm not sure.
Because I don't remember it, it means it probably was answered well.
Can you get a break now?
Oh no. Oh no. Okay, continue? Yes? So, next now, 11. Um, 11. A couple of people got this right. So what you have here are ocean waves, and their lengths, their wavelengths, they say 1.43 meters, and yeah, so what's happening here is there's like a boy sitting in a boat tied to the dock. So the boat rises up and down 11 times per minute. So per minute the boat rises how many times? 11. So then the time for one cycle would be 1 over 11 minutes. 1/11 of a minute. So that is equal to 0.09090 minutes. But of course you don't want minutes, you want seconds. So the time is equal to 5.45 seconds. Now what am I asking you for? The V. So V equals lambda F. But don't forget that F equals 1 over T. So this will be lambda over T, which will be 1.43 over 5.45. Which is 0.262 meters per second. I think 3 people got this right.
Out of 8.
Yes. And I think you might have been one of them. Yeah, I know. I can't believe it either. Yes. This was a lot like the example I did in class on this lesson. In fact, I think it was practically the same. Oh well. Right, a girl walks between two speakers facing each other, playing the same music in phase. She noticed that as she walks, the music gets louder and quieter. The girl is walking 2 meters per second, and she hears the peak every 0.7 seconds.
I think I'll direct nonsense for this question.
What is the frequency of the music? Right, so what's happening here? There's a speaker here, and there's a speaker here, and there's a sound wave coming out of this one, and then there's a sound wave coming out of this one. And what's going to happen is it's going to make this standing wave pattern where these are nodes, and then here are the antinodes. Yep. Now, as the girl walks from one speaker to the other, she hears it getting louder and quieter. So the peaks of loudness happen at the antinodes. So if you were to walk basically, as you walk, every time you hit one of these antinodes, you hear the music extra loud. And every time you hit the nodes, it sounds extra quiet. Anyways, the girl is walking at 2 meters per second, and she hears these, like for example, if I just use this one here, from here to here, it takes her 0.7 seconds to travel between, I think, the peaks. Yeah. And she's walking this fast, and it takes this long between the peaks. So I want to know the distance. So this is just, it's not even acceleration, it's just distance, speed, time. So the distance is the speed multiplied by the time. So 0.7, the distance, I'll say, 0.7 multiplied 2, that's 1.4 meters. Now that's the distance between the antinode and the antinode, which is not one full wave. If you look here carefully, it's only half a wave. So if you wanted the wavelength, it'd be twice this. What do I actually... Yeah, and actually I don't even want the wavelength, I want the frequency. Right, so frequency... I could say frequency is 1 over time. Do I have the time? No, evolving that way. What is the frequency? Okay, so the frequency is 1 over the time, and the time is... Oh, sorry, and we also have this formula. V equals lambda f. So F equals V over lambda, which is 340 speed of sound, divided by the lambda. One to 1 meter, no, not meters, talking about hertz. No, because that T is not the sound's time, it's the girl's walking time. Yeah.
Can we use the formula that has small d and d and s?
Not for this one. Not for this one, no.
I think I use it. I don't know.
Maybe. Right, so now on to section B. You really need a break? You're that weak and tired? Alright, I'm deadly serious. Wait. Deadly serious. 5 minutes. Right. Newton's 3 laws. Law the first. Come on. Newton's three laws. Law the first. It is?
Is it the first law?
Law the first, yes, is the first law. Newton's first law is Newton's first law. What is it? For every action, there's an equal and opposite reaction. Second law, F equals ma. Third law, no. First law is a body at rest or in not in a uniform motion. Constant motion will stay at rest or in uniform motion unless acted on by an external force. Second law is F equals ma, and third law is for every action there's an equal and opposite reaction. So I won't bother to write that down. That is 6 marks. Right. Next one is the graph, which is nobody used graph paper. It was disgusting. I got some disgusting graphs. Thing of nightmares. Right. So starts at 9 and accelerates for 1 second, continues, and then decelerates. Okay, so the graph. So this is B1B. Now my graph is supposed to look ugly. Goes up, across, and down. And this time, this is 1 second. So this is time in seconds. And here's velocity in meters per second. And this here is 6 seconds. And this here we don't know. Let's just call it T. And it starts at 9 and it starts at 9, and if it accelerates for 1 second at 9 meters per second squared, then after 1 second it will be at 18. Continues this for 5 seconds, and decelerates with -6. So it'll take, well here the last piece you could work it out. U equals 18, V equals 0, A equals -6. What's the T? Well, if you just use V equals U plus AT, you'll get the T is 3. So here this is 9 seconds. So that's the graph, and then the next part is calculate the total distance. So that would be this area plus this area plus this area plus this area. So the total distance would be 9 plus a half 9 times 18, so that's 81, plus 5 times 18, that's 90, plus 3 over 2 times this, because this is 3 and a half of 3, okay, times 18, so that is, goes in 9, so that's 27, I think. So 9 plus 81 plus 90 plus 27, something, spider senses, something feels wrong. 207. Here. This triangle's height isn't 18, its height is only 9. So this one here is a half 9 by 9, so it's a half of 81. So it's 40.5. Alright, that seems better. 166.5 meters. Yep. And the last part, D, is how much force was required to bring it to rest. So that's easy peasy. I think everybody got this right. F equals ma, and the m is 10, and the a at the end was -6. So you required 60 newtons of force to bring it to rest. That section B question took nearly the same amount of time as a section A question. Why people did so badly? Yeah, but most people's graphs were ugly like this. So it shouldn't have taken you long to make such an ugly graph as well. Okay. Wait, did I skip a C part? Oh, that's the C here. Sure, I might as well write the A part in. So Newton's first law, Newton's second law, Newton 1, Newton 2, Newton 3. So Newton's second law is F equals ma. Newton's third law is for every action there is an equal but opposite reaction. F equals ma, and Newton's first law is a body at rest or in uniform motion. I'm not even going to write the rest down. Blah, 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 blah. You know how the story goes. You should. So, I mean, my goodness, this wasn't that difficult of a question. Really wasn't. Okay. I think a common mistake people made with this graph was they started at rest. Maybe, I don't know, three people did this. Most people had the right shape, but an ugly graph. And again, I don't know. I think this answer was wrong for most people. I think most people made a small mistake, like I nearly did, with things like the height here. I don't remember. Okay, so write whatever you need down from this, please. Yeah? No, you have everything you need? Yeah? Alright. B2. Nobody successfully solved the three equations. It was a disaster. Nobody successfully solved the three equations. Although many people successfully produced the three equations, nobody solved it. In fact, some people didn't even bother to solve it. They just said, here are the three equations, solve them yourself, I'm going home. See you next year. Good luck with that. Right, so I wonder if I can copy this diagram somehow. I can like right click it. I don't want to copy the whole page. No, that's not doing it. I need like a snapshot tool. Yeah, I can do snapshot.
There's a button on the key, no?
There's print screen, but I don't really want to do a print screen. I'd rather just copy the bit of the graph I need. Huh? Yes, let's have a look. Alright. Come on. Oh, caramba. Right. Tools. New laptop is happily on my coffee table. It's too new for you. Maybe next year. Yeah.
Said the same thing last week.
Oh yeah, but I mean it this time. Come on, tools.
Use print screen.
I might have to use print screen. Yeah, but maybe if I use it with this. No. Alright. Let's try to remember this. So we have R1, 2, 3 down the bottom. We have an E1 and an E2 and the currents 1, 2, 3.
Yes.
Alright, let's try our best. Alright, so we have an R1, R2, R3. And then, well, we definitely want to make sure this is the right way around. So that's one this way. That's one this way. And then they all connect up to
This is loop.
they all connect up to 1 like this,
Yeah.
and then the same.
Yes.
There's a loop.
Yeah. So this one here, and this is an OR1, an OR2, and an OR3, and the voltages are 1 and 4. So this is 1 volt, and this is 4 volts, and then the currents, I drew them going 1 down, left, down. So the currents here, this one is I1, this one is I2, and this one here is I3.
Yes.
Alright, so my first question was probably write the equations down, wasn't it? Oh, goodness, alright. Right. Okay, this one is actually answered well enough. Kirchhoff's first law? Is it junction or is it loop? I always mix them up. Junction first law? Anyways, Kirchhoff's first law, the junction law, is that the total current entering a junction must equal, the total current entering a junction must equal the total current leaving the junction. So as a formula, his junction law says the total current at a junction must equal 0. And his loop law, the total voltage around a closed loop in a circle, in a circuit, must be also 0. And then in part B, you have to say what these are the conservation of. So this is the conservation of charge, and this is the conservation of energy. State Kirchhoff's 2 circuit laws. State what each of Kirchhoff's laws, I suppose I should have an S here, are the conservation of. So this part was answered reasonably well. Everybody knew the Kirchhoff laws. True? True story. Yeah. Yeah? Now, the big part. I give you the currents now. Sorry, 97, 220, and 318. So, this one here, oops. I'm in some weird eraser mode. This one was 97 ohms. What did I say the other one was? 220 and 318. I'll have to fix that now. What the heck? Come on. Give me my pen back. 318 ohms, 220 ohms, 97 ohms. Sorry, mine is ugly. Okay, so what did I want? Yeah, so part C was just to make the equations. Right, so junction first. So the first one would be the junction one. So that would be I1 minus I2 minus I3 equals 0. Loop 1 next? Loop around the 4 maybe. So if we start here with the 4, I'll write it here. Oh no, I kind of have to squeeze down. Sorry about that. Right, if I start here with the 4 and go to the right, I would have 4 to
Okay.
the right.
Starting from
4.
okay, the whole.
There's only one 4. Starting from the 4 and doing a big loop around.
Okay.
4. Well, you know what? Actually, I think it'd be easier to start with the 1 next. So starting at the 1, and I'll loop the top. So I have 1 volt minus 97I1 minus 220 I2 equals 0. Okay, so the third one. Now, you could start with the 1 and loop at the bottom. But this battery is a bit weird because it's the right way, but the current going through it is backwards. But anyways, it doesn't matter. Let's see what the heck happens if I do this.
Go with the 4.
Go with the 4. Maybe I want to go with the 4. Go with the 4 to the right. Alright. No. Yes. Maybe. Alright. 4 plus 318I3. Why plus?
With
Yeah, the current's going the wrong way through the resistor. Minus 220 I2 plus or minus this I1 plus this 1 equals 0.
in case you should, make the other one too. You can check it afterwards.
You can make another one, yeah. Okay, can I scroll down? Right, so let me just clean these guys up a bit. So the first equation can be written as I1 minus I2 minus I3 equals 0. And then here, minus 97 I1 minus 220 I2 plus 0 I3 equals minus 1. So let's get rid of those ugly minuses. And then the third equation, 0 I1 minus 220 I2 plus 318 I3. 4 plus 1 is 5 to the right. So part C of the question, no, part D of the question now is to solve these. Now, in the exam, I think I typed something in wrong here. Right, first one is 1, minus 1, minus 1, 0. Then 97, 220, 0 and 1, 0, minus 220, 318, minus 5. No, I got small answers. So here I1 equals minus 4.6 milliamps. I2 equals 6.57 milliamps. And then I3 minus 0.0111, so what's that, 11 milliamps, 11.1 milliamps. Now look, your calculator can solve these problems for you. If you type in Now, of course, you can't do this in the exam, but you can use this to check your answer. If you type in mode 52, mode 52 will solve this system for you. Is it mode 52? Yes, it is. No, it's my calculator.
You want to see?
No, it's mine. I'm using it. You can see there. But this, of course, is not what you need to do in the exam. What you need to do in the exam is solve it by hand. So what would be the best way to put these equations together? Any ideas?
Using somewhere.
Yeah, but what should I cancel with what? What? Wait, what class am I in now? What is the best way to solve this? I mean, what one should you put with what? So, I mean, you could cancel the I2 from the second and the third easily, couldn't you?
No.
You could, just add them together.
They'll add up.
Add them together, plus 220 and minus 220 will cancel. Take the headphones out. Now, the next time you come into my class with them in your ears, I will take them, give them to the principal, and you can explain to her why you feel the need to have them on in my class. If you add the second and the third together, the I2s will cancel, and you'll be left with I1 and an I3. I think what I'll do is I'll multiply the first one by 220. So I'll just write it in here. 220, 220, 220. And then what you can do is equation 1 plus equation 2 and equation 2 plus equation 3. Because when you add the first two together, what cancels? What will cancel if you add the first two together? No? I2 will cancel. And if you add the second and the third together, what will cancel? I2 as well. So let's add the first two together. So the first one plus the second one, what will that make? That will make 317 I1 minus 220 I3 equals 1. And if you add the second and the third together, you'll get 97 I1 plus 318 I3 equals 1 minus 5 is minus 4. Now this is just a degree 2 problem, and you have many methods in maths class to solving this. What are those methods? Except that one, of course. Gaussian, elimination, substitution. So I'm not even going to insult your intelligence by doing that for you, and I'm just going to give you the answer. So if you solve this one, you would get I1 equal to minus 4.6 10 to the minus 3, so milliamps. And then you would get I3 equal to minus 1.1 milliamps. If you take these two answers and put them into, say, this one here, you can get the I2. And when you do that, you'll get 6.57 milliamps. So that's the same answers from mode 52 on the calculator, which means you did the question right. So look. By adding these two and these two together, you've made a very simple problem. And when you solve this very simple problem, you already get two of the answers. Subbing these back into the first one gives you the third answer. So I don't know why people screwed it up so badly, but nobody got these three answers. It was amazing. Amazing. All the answers are small, so they'll all be in milliamps. Okay, the D part. what way are the electrons moving in the 318 resistor? So the I3, positive or negative? Negative, right? So that means your current is not going as shown on the diagram. The current is actually going this way. So if the current is going to the right, it means the electrons are moving to the left. So the answer is to the left. Or if you want, you could say it's going clockwise. Whatever way you describe it. A lot of people just said to the left or to the resistor or whatever. That's fine. So the answer is clockwise. And that is Kirchhoff. So lastly, the waves. I don't think there's time to do all of this. Well, we'll just do the start of it. Let's see what you remember. So describe, what a longitudinal and a transverse wave is and give an example of each. Well, let's see how far we can get. We'll stop if we run out of time. So B3A. So longitudinal, that is when it oscillates. That's longitudinal. What's this one? No, are you sure it's not this one? Are you sure? How much are you willing to bet? No, it's a good question because you see how confident the person is. So, what do you think?
I think it's pretty correct.
You think it's this one? I don't know, dude. I think it's this one. No. I mean, this is. Computer's not on. Doesn't matter. Go on. Take out your phone. Type it in there. You never talk about it. I can't see. Wait. Where's it? Longitudinal. It's this one, isn't it?
Yeah.
Dude, I think it is this one, dude.
Yeah, that was it.
No, it's not this one. It's this one.
Compression and...
Yeah. Yeah.
I thought that's what...
You doubt it yourself as well, huh? Right, so it oscillates in the direction. Now, what's the verb for when we're talking about waves that means movement? Propagation, yeah. Oscillates in the direction of propagation. I guess that's how you spell it. Yeah, I just turned it on. Give me an example of a wave that's like this.
Electromagnetic waves.
No, dude. Sound. Transverse, it's the same except it's perpendicular. And an example is an electromagnetic wave. It's light. Yeah? Alright, so the B part, what are three properties of electromagnetic waves? Number one, they can move in a vacuum. Number two, they travel at the speed of light. And number three, they're always transverse. Aren't they? So these are three properties of electromagnetic waves. Huh? Speed of light. That's in other words, their speed is the speed of light when they're traveling in a vacuum. Vacuum, it means they don't require a medium. Okay. C. A diffraction grating has 328 lines per millimeter. What is the line spacing of D? So, okay, it has 328 lines per millimeter. 328 lines per millimeter. So that means the spacing would be 1 over 328 millimeters. So the space between them would be 3.05 micrometers, 10 to the minus 6, because milli is 10 to the minus 3. So that's how much space is between each slit. Okay. D, what is the color? You shine some light on this diffraction grating, and the wavelength is 638 nanometers. What's the angle for the second order? So you have your grate here, and your light comes in, and what did I say it was? 638 nanometers. And you have order 0, order 1, order 2. We want this angle here. So our formula, do you remember it? It's n lambda equals d sine theta. So theta is sine inverse n lambda over d, which would equal sine inverse 2 times 638 times 10 to the minus 9 all over 3.05 times 10 to the minus 6. So we can calculate that, no problem to us. 2 times 638 times 10 to the power of minus 9 over 3.05 times 10 to the power of minus 6, and you get an angle of 24.7 degrees. Next part is, what colour is this light? Oh, jeepers, I'm nearly finished. What colour is this light? I think this is, I don't know, 650 is red. I think it's red. Red. And then finally, what is the biggest order? So the biggest order is when the angle is 90. So you want theta to equal 90. So that means you want n lambda to equal d sine 90, and sine 90 is 1. So then the biggest n could be is d over lambda. What did I say the d was? 3.05 times 10 to the power of minus 6. And the lambda was 638 nano. So when you type those two numbers in, you get 4.78. So the biggest order, the maximum, is it 4 or is it 5?
5.
No.
I mean, it's,
No, 4.
because the fifth one is incomplete.
It's impossible. It would exceed 90. Fifth one cannot be achieved. Only everything up to 4.7 can be achieved. And 4.7 doesn't make sense. So only everything up to 4 can be achieved. So the maximum order is 4. So I did this whole exam. Let's see, how long did it take? We took a break in the middle, and I probably didn't really start until about 6 or 7 minutes past 9. And what time is it now? It's not even 10 to 4 there. I probably spent 90 minutes on the exam. And that was enough time to do everything in the exam. How much time did you have? 2 hours. And did you have to do everything? No. And did you have a formula book?
Yes.
And were some of the questions similar to what we did in class?
Yes.